There are many worlds within our solar system. Most reside beyond the asteroid belt. These are the moons of the gas giants of the solar system, each a unique and mysterious world of its own. Some have oceans of water, geysers of sulfur, or atmospheres of plastic. Some are just now being seen at the outer rim of our solar system. All are worthy of much more scrutiny. Currently en route to the Jupiter system is the scientific probe Juno. It will be the first orbiter mission to Jupiter since the troubled Galileo spacecraft in 2003. Its task? To establish a highly elliptical polar orbit and study Jupiter in the greatest detail so far. Several other probes have made flybys of the system en route to other destinations. Some of these returned fascinating data on the Jovian moons. Jupiter, the largest planet in our solar system, has, as far as can be ascertained, 67 orbiting satellites. Most of them are odd-shaped rocky masses, probably asteroids like Amalthea, trapped in the massive gravitational field of the planet. However, there are 4 major satellites of Jupiter, each large and dense enough to form spherical bodies. These are called the Galilean moons, named after the great Italian scientist and astronomer Galileo Galilei, who discovered them in 1610. Io is the smallest of the Jovian moons, though somewhat larger than our own moon and closest to orbit Jupiter. The intense gravitational effects causes the violent and active nature of the moon. It has over 400 volcanoes, lava flows, and plumes of sulfur 300 kilometers above the surface. The most dense of the 4 moons, Io is also the driest. Io is thought to be composed of mainly silicate rock with a molten core of iron or iron sulfide. Most of the surface is composed of extensive plains coated with sulfur and sulfur dioxide frost. The surface is geologically young, which accounts for the lack of impact cratering. Unlike all the other planetary bodies, these craters have been covered over by volcanic activities. Numerous active volcanoes also eject material high above the moon and into orbit around Jupiter. The internal energy for this overactive moon is due to gravitational tidal forces between Jupiter and the other moons orbiting further out from Io. Just slightly smaller than our own moon, Europa has an icy crust covering what is believed to be a salty global ocean capable of sustaining indigenous life. It also has active geysers ejecting material into space.
So how do we think we know that Europa's ocean exists? Well, it's a combination of using telescopes on the ground and having spacecraft that have flown by Europa and collected data about the surface, about the interior structure, and about the magnetic field around Europa. And the combination of those data sets leads us to a high degree of confidence that this global liquid water H2O ocean is there today and it's been there for much of the history of the solar system. And here's where Europa is a real game changer. It is far, far out from the sun, and yet it's got this liquid water ocean. And the reason that Europa has liquid water is because it's orbiting Jupiter, and the tidal tug and pull causes Europa to flex up and down, and all of that tidal energy turns into mechanical energy, which turns into friction and heat that helps maintain this liquid water ocean beneath an icy shell. Along with helping maintain liquid water, we think that tidal energy may also allow that ocean to interact with rocks on Europa's seafloor. And it may even give rise to things like hydrothermal vents, which could help provide not just the building blocks for life, but also the energy for life.
Europa is the most likely place to find life in our solar system today because we think there's a liquid water ocean beneath its surface. Now we know that on Earth, everywhere that there's water, we find life. So could Europa have the ingredients to support life?
We might be actually looking at a body that is presently alive, presently active, and presently undergoing its geology. There is too much evidence right now lying around on the surface, the red stuff, that suggests that something's going on there. Is that an environment that is habitable for any sort of life form? By golly, we really have got to go back and figure that out.
We have designed the Europa mission to take a spacecraft and its set of instruments all the way from planet Earth to Jupiter.
Previous mission concepts were for a spacecraft that would orbit Europa. But Europa is bathed in radiation from Jupiter. Any mission that goes in the vicinity of Europa is cooked pretty quickly. Instead, we're looking at a mission that will orbit Jupiter, make close flybys of Europa, and then zip out of the high radiation region. This allows us to have a mission that's many years long and to collect and transmit lots and lots of data. As Europa orbits Jupiter, it flexes, and we could measure the gravitational change of Europa by encountering Europa at different points in its orbit. On a typical flyby, we would turn on our remote sensing instruments, we would image the surface, we would interrogate the surface with spectroscopy, and we would do the same thing on the way out. And we would essentially rinse and repeat, and do this many, many times until we understand Europa globally.
Images from the Hubble Space Telescope tell us that Europa might be emitting plumes of water high into space. If so, a spacecraft could fly through those plumes and sample it directly to understand the composition of Europa's interior.
If it does have the ability to harbor life, how does that work exactly? We'll have enough instrumentation to really pinpoint exactly how the mechanisms would work for replenishing the nutrients in a subsurface ocean.
Europa is so important because we want to understand, are we alone in the cosmos? If there's life in Europa, it almost certainly was completely independent from the origin of life on Earth.
And for the first time in the history of humanity, we have the tools and technology and capability to potentially answer this question. And we know where to go to find it. Jupiter's ocean world, Europa.
The Europa Clipper mission has passed preliminary development and strategy proposals and acquired further funding. The European Space Agency has been invited to develop an additional probe to ride along with the Clipper, as with the Cassini-Huygens mission, and either land or impact on the Moon's surface. The nominal Europa Clipper mission would perform 45 flybys of Europa at altitudes varying from 2,700 to 25 kilometers. A proposed launch window would be in 2025. If launched with NASA's new SLS heavy-lift rocket system, the probe would take less than 2 years to reach Jupiter. Otherwise, it will be a 6.5-year flight. The largest moon in the solar system, and another icy world, is Ganymede. Composed of silicate rock and water ice, the surface is heavily pockmarked by impact craters and regions of tectonic movement. The Moon has a thin atmosphere of oxygen and possibly ozone and atomic hydrogen. The Moon has a liquid iron-rich outer core and an internal ocean, with possibly more water than Earth's oceans. Most recent modeling suggests the interior may be layers of water and ice, like a club sandwich. Ganymede is also the only moon known to have a magnetic field. However, it is embedded within the powerful Jupiter magnetic field and overwhelmed. But there are indications of auroral activity on the Moon. Ganymede is also the final target for the Jupiter Icy Moon Explorer, or JUICE, the ESA-designated mission to 3 of the Jovian moons. It will be launched in 2022 from Europe's spaceport in Kourou, French Guiana, on an Ariane 5, arriving at Jupiter in 2030 to spend at least 3 years making detailed observations. It will visit Callisto, the most heavily cratered object in the solar system, and will twice fly by Europa. Callisto is the 4th and most distant of the Jovian moons from Jupiter, and outside the main radiation belt of that planet. Unlike its sister moons, Callisto has a very thin atmosphere of carbon dioxide and molecular oxygen, and low radiation exposure. Callisto is composed of silicate rock and water ice, and may also harbor a subsurface ocean. It is considered the most environmentally acceptable location for a manned base in the future. Saturn has 62 confirmed orbital satellites, many less than 50 kilometers in diameter. The bulk of the larger spherical moons are predominantly water ice and a small amount of rock. They include Mimas, Enceladus, Thetis, Dione, and Rhea. Enceladus is covered in ice with a subsurface ocean at the southern pole. Geologically active in the southern region, geysers have been observed. This would be from tidal heating and orbital resonance with Dione and Rhea, and could contain a liquid ocean heated by internal radioactive decay. However, the prize of the Saturnian system is undoubtedly Titan. Titan is the only moon with a dense atmosphere, and, other than Earth, the only body to have stable bodies of surface liquid. It is larger than both the planet Mercury and our own moon. Cassini deposited the probe Huygens on its surface in 2005.
Titan is Saturn's largest moon. It's actually the 2nd largest moon in the solar system, and it's the only moon in the solar system that has a large and substantial atmosphere. And that atmosphere in some respects is really similar to that of the Earth, being composed mainly of nitrogen, but in other respects it's really different. It has methane as its 2nd most abundant gas, and that takes the same role as water vapor in the Earth's atmosphere. It evaporates from the surface, it forms clouds, and then rains down again, and in fact forms lakes that we see at Titan's North Pole, including ethane and propane and all sorts of complex chemicals. We also see these vast dune fields at the equator, which are not made of silicates as they are on the Earth, but actually made of organic substances, essentially plastics, which have actually sedimented from the atmosphere and are being blown around into dune fields, the same as we'd see on a desert on the Earth. And through this we can detect which molecules are in the atmosphere. We see all the molecules that were previously discovered by Voyager. But we're also able to look for new molecules, and in fact, buried within the signatures of these more abundant molecular species, we saw a very small spike, which was due to a new species which had not been seen before. In fact, this was propylene. So the discovery of propylene on Titan is really exciting. First of all, it completes this chemical family where we had this missing link dating 32 years back to Voyager. But also it shows that there's much more there still in Titan's atmosphere to be discovered. Some people think that Titan is similar to the prebiotic Earth long ago, when the molecules were forming the basis of life. And we don't know what we're going to find on Titan if we send back further spacecraft with new instruments, more sensitive instruments, if some of the molecules on Titan could be similar to the basis of life on Earth.
NASA is preparing a new probe to follow in Cassini's footsteps. It is called the Titan-Saturn System mission.
Cassini was able to look at the lakes, get a sense of the coarse composition of the lakes, but nothing about the organic molecules that are dissolved in the lakes. The Titan-Saturn System mission is a 3-in-1 mission with an orbiter for Titan, a balloon that will float through Titan's atmosphere, and a lander that will splash down on one of the northern lakes of Titan. This mission will actually go into a lake, sample the liquid directly, see what the organic molecules are that are present. The Titan-Saturn System mission also will go to Enceladus, the tinier moon, 1,000 times smaller than Titan, which has volcanoes, geysers essentially, that are spewing material from the inside of this moon outward. And it's a chance to see whether there might be molecules that would indicate that life has actually formed within the source region of these geysers. These geysers have water ice, and we strongly suspect that there's liquid water in the region that these geysers are coming from. We know there are organic molecules there because they've been measured by Cassini. The ability to follow this up quickly is essential because with Cassini-Huygens, we have now trained a generation of scientists who are ready to take a new generation of instruments and capabilities back to Titan and Enceladus and really answer the questions that Cassini-Huygens has left for us. And that continuity of knowledge and of enthusiasm is essential and very difficult to maintain in the outer solar system because trip times are so long. The Titan-Saturn System mission really is Jules Verne realized. It's a kind of planetary exploration that we have never ever done before anywhere else in the solar system and can only be done on Titan. This mission will touch the human heart in terms of the way it's exploring this fascinating world. It will be floating on the surface of a lake. It will be floating through the atmosphere. It will be revealing the entire surface from orbit at the same time. As we think of exploration, of unveiling a new world, it's exploration in the true sense of the word.
The planet Uranus has 27 known moons, grouped in 3 categories: 13 inner moons, 5 major moons, and 9 irregulars. Only Voyager 2 has passed by these worlds. There remains much to learn. The major moons in order from the planet are Miranda, Ariel, Umbriel, Titania, and Oberon. 4 of these moons have known internal processes such as volcanism and surface canyon formation. Miranda is the smallest of Uranus's round moons and one of the smallest objects in the solar system to be spherical under its own gravity. Strangely, it also has the tallest cliffs in the solar system. Thought to consist of equal parts of rock and ice, Ariel's surface terrain, probably of ice, is cross-cut with canyons, scarps, and ridges. Umbriel is again thought to consist of rock and ice. Its surface is the darkest of the moons and heavily cratered. The surface seems to have gone through some form of surface heating that destroyed its very early features. Titania is the largest of Uranus's moons. Similar in composition, heavy cratering has been obscured by changes to the surface through some heating event like its sister Umbriel. Titania may have a tenuous atmosphere as carbon dioxide and water ice have been detected on its surface. Oberon, the outermost of the spherical moons, seems similar to the others: ice and rock and heavily cratered. The surface has numerous scarps and graben from crustal movement. There are currently no plans to revisit these worlds. Neptune has 14 known moons, categorized into 2 groups, the regulars and the irregulars. The inner 7 moons orbit normally. The remaining half, including its largest moon Triton, orbit in either an eccentric inclined or retrograde motion. Triton orbits in the opposite direction to Neptune's spin. Scientists believe it was probably captured by Neptune's gravity in the early days of the solar system. Triton has an atmosphere that forms clouds and haze, and is the only moon closely observed by Voyager on its flyby of the system. However, Neptune plays a very important role at the edge of the solar system. The planets formed from a disk of dust surrounding our Sun billions of years ago. Remnants of this disk still remain: the rocky asteroid belt influenced by Jupiter and the icy debris cloud beyond Neptune.
Neptune creates a ring structure in the dust cloud which features a gap where the planet itself resides. And this gap should make it fairly easy to tell where Neptune is from afar, even at distances where the planet is too dim to detect directly. The supercomputer simulations that Mark Kushner and I performed also allow us to see what the dust in the solar system may have looked like when the solar system was much younger. In effect, we can go back in time and see how the distant view of the solar system may have changed. When we included collisions between dust particles, we were really amazed by what we saw. Dust collisions change Neptune's gravitational imprint. The gap in the ring structure disappears.
Over billions of years, Neptune shepherds the dust cloud into an outer ring to what is now called the Kuiper Belt. The New Horizons spacecraft is exploring this region with its first flyby of the enigmatic Pluto and its moon Charon. Charon is the largest of Pluto's 5 moons. The other 4 orbit in erratic motion around the Pluto-Charon pair. Nix and Hydra are both odd-shaped, contributing to their erratic orbital motions. This is Hydra, taken by New Horizons from a distance of nearly 650,000 kilometers, revealing its irregular shape. Pluto was the first of these trans-Neptunian objects detected and first thought to be a 9th planet.
And then Pluto was this kind of, odd guy out. It was this little object at the edge of the solar system. And then when we found all these other Kuiper Belt objects, this is kind of almost a 3rd type of object.
So for the first time ever, we'll be able to fly by a brand new object, an object that's been forming for billions of years, and understand what outer parts of the solar system are all about.
Pluto is the first of the Kuiper Belt objects, or KBOs, to be seen up close. There are many other KBOs, or dwarf planets, awaiting detailed scrutiny, such as Eris, almost the size of Mercury, and Quaoar, the first KBO discovered. The most eccentric orbit belongs to Senda, which has an elliptical orbit of 11,000 years, taking it to the icy Oort cloud at the edge of the solar system. The Oort cloud will one day become the new frontier.